we know how we can solve it in manual. Okay, basically look into its so-called orientation itself, then probably we can solve the problems. But then in a case problem study like that, then I think we leave it to the software to help us to solve it. So, okay, but the fundamental is there. We have to first find the each member's local so-called stiffness matrix, transform it, then transform it to the global coordinates, then only you start solving it, something like this, or it will happen. So again, this is not 2D, okay? It's not in terms of X, Y, so you also have the Z directions coming into play, okay? So if you are just the front part only, then probably yes, you are in the X, Y directions, then that 2D itself or transformation matrix is 6 times 6. Matrix itself is sufficient to solve that particular problem, but involving more so-called elements in this case. So we let software, okay, we try to use how if we what we have learned in the theory parts, we try to apply in software using ANSYS Workbench, see how we solve these particular things, particular problems, right? So that is a frame problems of basically representing a low-rise buildings. Here is a two-story buildings with structure I-beams. Okay, the deformation stress, we have to determine the deformation and the stress. Okay, if you have a uniform load or distributed load of 50 kilonewton meter applied at the second floor. Okay, as you have seen here. Right, so it's a 6 meters width. Okay, 6 meter also at here. Then the height itself is these two beam. If you can see, this two beam itself is this beam is 6 meter, then this beam is higher at 7. Okay, in between here to here is 7. Okay, so here to here itself is just 7. 1 meter each difference, right? So it's an I-beam size with all the information is given. Okay, the I-beams are W356 times 171. Then the depths with thickness are all given here. So let's try together. So, okay, maybe I can show you how to solve it using ANSYS. So I will try with design modeler first. Later on, I will just show you how you can do it using what we call space screen also. So static structures coming in, right? So start with this engineering data. If you double click on it, so of course the structure still, you don't need to change anything because this problem itself is using this model, this material, so it's structure still. So we don't need to really add another new model, a new materials or what. So then we just stick with this structure still. Then you come back to projects. So we go to geometry. Again, this is a line body, so we have to check these line bodies. Then we can right click or choose which one you want to use. Or here I will start with a design modeler. All right. So it will show start design modeler. All right. So here we go. That is what we call the interface of this design modeler. So we are drawing in XY planes. So we have this XY plane, we click on this, then we create new sketch. All right, so that is a new sketch. Now we can draw anything on this XY plane. So you can look into just in this particular XY plane. So if you are familiar with the grid, because these are quite standard what we call dimensions, right? So we can call out the grid. So sketching, setting, then you can call out the grids. So easy for us. So major, you can put 5. Okay, so here to here is a 5 meters. Then minor, each minor step is 5 also. So you have each minor is 1. Okay, so if you zoom in, right? So if you can see probably here, okay, 0 to 5. So each minor is 1 meter, 2 meter, 3, 4, 5. 1, 2, 3, 4, 5. Again, you have to check your units. I'm using meters. All right. So we can start draw this so-called structures. Okay, the frames. So we can draw line. So we can start from here. Okay, you have a 3 meters. 1, 2, 3. All right. Then it connected to 1, 2, 3, 4, 5, 6. Right. Then coming down here, 3. Same with here, 6. Then 3. Then here we go up 3 meters. Here we go up 4 meter. Right, 1, 2, 3, 4. Here we come up another 3 meter. Then we connect both sides. Okay, so we try the plane first. So the whole idea is you get this body out first. So that gives us the I think the similar model that is given in the problem, right? So what you can do now is you click on the sketch, okay? Then you go to concepts. This is just a sketch. You have to create this line from the sketch itself, okay? So what we do is we create a line from sketch. Then you can apply it, okay? That sketch one, and you generate. So now you will have one line bodies, okay? Which is, if you look into this, then you have this. So you do, maybe you can turn off if you want, okay? You can turn off the grid, maybe you not needed it anymore, okay? That give you this. All right. Then next is we have to what it does. I mean, in the tutorial, basically you have to translate these particular line bodies. Okay, basically you duplicate another line body, which is the displacement is basically 6 meter, okay, away from here. So we duplicate another one, which is at the back, okay, back of this body. So it's the negative z directions. So what we do is you go to under modelings, okay, this line body itself, then you go to creates, right, body transformations, translates, right? So if you click translates, then the whole body you want it to apply, then you want to also not just translate, you also want to preserve this particular body itself. Then we want the directions to be in coordinates. I'm going to go -6 meter. So you have one another bodies. If you look into this, another second body coming in to here. Okay, so now basically you give both sides have basically displaced by 6 meter. Right. Then I can click generate. So then now you have two bodies. Okay, line body 1. Okay, line body 2. Then we have to so-called connect the lines. We connect the lines. Okay, basically we need these to be connected. Okay, for all of them. So, okay, 6 line. We draw 6 line. Then we basically complete the line models. Okay, the line body itself. So what we will be doing is we go to line concepts, line from points. Okay, so if you click on this, then you can actually draw the line. So you click control, okay, then you select 2 point, F. Hold on the control, then you select these 2 point, then it will draw a line. Okay, so again, click on this to another point. That give you the 2 line. Okay, so you hold on the what we call the control, then select. So you will draw a line. Right. So that gives us all the line that we have. So if I click generates, okay, then everything now is connected, right? So the two body now become all with the line itself become one bodies, right? So next will be putting in the cross sections. Okay, you will see this. There is a yellow box here. Cross section is not selected. So what we need to do is we have to assign a cross section for all these particular line models. Okay, so here we go to cross sections. Then we have these eye sections. If you click on this, then we have to determine the dimension of this eye. So follow the tutorial or as well as the question itself. Then your W1 is your W1 is a 0.1715. Right. W2 also is a 0.1715. W3 is a 0.3556. W4 is, if you follow it, is a 0.0073. Here also 0.0073. D3 is 0.0115. So that gives us our cross sections of this. So we can click generate this thing. Okay, so that is our cross section. So now we can assign our cross sections to this particular frame itself. If you click generate, then here, if you are going to view cross section solids, that give us our models. Okay, the line with cross section. But here, if you look at these few beams, the horizontal beam, 1, 2, 3, 4, 5, 6, 7, 8. So these lines are all, if you can see it, it is the beam is not I beams. It is actually in H beam orientations, right? It's not really I beam. So what we need to do is if you put like this, so basically it won't take too much load. It bend a lot because it's not strong enough in these directions. Okay, so you have to translate, orientate it into the correct directions. Okay, so what we do is you have to select them and orientate them. Okay, so here if you go to line, so if you can go to line, then if you can go to here, okay, under these line bodies, then if you want to turn off the cross section also can. So basically it's line itself only, right? Then you would want to select lines, the edges instead of the points or the vertex. So you select this, then you can select this line. Okay, you can click all of them by clicking on control and select them. This for 8 of them, you have to rotate it of 90 degrees. Okay, so if I have rotated 90 degree, so if you look into its cross sections now it is in I beam. Okay, so now it's a correct orientations. All of them is in the correct orientations, which is 90 degree, which is the real I beams rather than H beam. Right, then you can generate. Okay, so that gives us our so-called result. So if you can look into this itself, right, so it is now have been oriented. So here no issues. Okay, this side are all I, so this side just now is in H, so we have changed everything to I, right? So that basically completes your so-called models. Not too slower, it's quite fast also, right? So you can close it. Then we can open up the mechanical under model. So if you double click this, it will be starting mechanicals. All right. All right, so it have imported the model from the design modeler that we have drawn. So if you can go to check your units, okay, is in meters, then we can go to display. If you want to call out the 3D types, then you can click on this, then you can really check, yeah, all are in the correct orientations. All right, good. Then you can actually start your top down again. Line bodies, you have to select the correct assignments on material, structural steel. So you make sure you, if not correct, then you have to choose the correct materials, right? Then you can follow back to cross section. Everything is right. Then you go to meshing. So in this case, we use 0.2 as given by your question. So if we use 0.2, then we click generate mesh, then basically it will give us something similar like this. Every 0.2 meter that is an element. All right. So if you want to investigate how many elements, you go to statistic, that is 614 elements, 1220 nodes. Right. So next we'll be going towards the setup pre-processing. We have the boundary and the load coming in. So here, if you can close these things, if you don't want it to be displayed, right? So it will be easier for us to do the selections. So we can go to insert a fixed subplot. So the base are all fixed. So what we need to do is just, you have to, now is in the phase, we have to choose vertex, okay, at here selections, then you just select all of them. Click and holding the control. Apply, then 6 vertices is actually assigned as the fixed subplots, right? Then we can apply our loads. So here is the pressures. So we are putting line pressure. Line body, we have a pressure, is a line pressure set here. So again, we have to select the line. So you have to make sure you are in the edges here, selection. So you can select by holding control and select. So together, you can do by one line for one line pressure, or you can do all select by using the control and apply. So 7 edges are now applying these line pressures. So here I want to use a component methods, so I can apply a negative 50,000 that particular line, or the second floor, okay, beams. All right, so that's all the setting. In fact, you can just straight start to solve it. So, but before it starts, we can actually go to call out what we want to look into. We want to look into the deformations, and we want to look into the so-called the results on stresses. So you can go to these beam tools that give us the direct stress, which is the axial related stress, and this combined stress is basically combining your stress, normal stress due to bendings, shear stress, as well as your axial together. Okay, so now we can solve it. You can play around with different mesh, and you can see the difference, because meshing, the mesh size is one of the factor that I mentioned to you before, is will affecting your results. Okay, the difference of the result. So usually, what if you are doing computationals, what usually we do, we will do a so-called mesh independent test. Okay, to check what is the suitable mesh size that should be used. So what we will do is we play around with different, maybe you can start from a very big number of meshings, okay, maybe 6 meter, because it's 6 meter is one of it, right? So if you put 6 meter, then probably is one element, right? So 6 meter, then you jump down to 5 meter, 4 meter, 3 meters. So you get the result. So here maybe you can use deformation as one of your comparison results, okay, output result. So at 6 meter, what is your deformations? Okay, at 5 meter mesh, what is your deformation? 4 meter mesh, what is your deformation? 1 meter mesh, what is your deformation? So you have to you have to get to a point that the deformations, okay, between the mesh itself, basically it doesn't deviate or change too much, okay. So that is a tolerance on the tolerance of what we call uh, uh, a percentage of changes that between the two mesh size that you use. Okay, then you can use the final one lah. I mean the one that basically before and after you refine, okay, is not much difference within a certain percentage is acceptable, then you use that particular the mesh size. So in this case, I will just say just put a 0.2 in this case. Okay, we are not going up to the extent that we have to find a suitable mesh size. Okay, of course you have to take note that this mesh size will affect your results. Okay, from a large mesh size until the small mesh size. Okay, large mesh size you will have the accuracy, you will compromise on your accuracies, but it's very fast. Okay, in terms of solutions solving. But if you are using very small mesh size, then probably you will get more accurate results. But is it needed in this particular so-called simple problem or not? Okay, so in this case, if you're using a final so-called mesh size, probably you will compromise on your computational times. So you have to give and take. So later on, we'll see how to get a suitable mesh size where you can play around. What we call here is a mesh independence test, right? Where you play around with different mesh size until to an extent that the mesh size doesn't really affect your results already, right? So that mesh size is a suitable mesh size that you can use for the remaining of the test, right? Of this particular problem. Usually in the problem I will mention, okay, what size you should use or so if no, then you use defaults. Okay, default, if you put 0, then it will be defaults, then you can generate. All right, so that will be even not that fine enough. Okay, so if I not mention, you can use default. If it's mentioned, then you can use the mentioned one. All right, so generates, then solve it against, then that give you your deformations. So this is the deformations, okay, 0.015723 meters. So it's around 15 mm and maximum in bands. So basically this thing will involve bendings or together with rotation. So come to get everything already. All right, so you have also the stress. Here is related to the axials, direct is axial stress. Then here is the combination of axial, normal stress due to bending and shear stress. Everything come together. Okay, so that is some examples. Okay, when you are dealing with frames. So I mean, this is a simple frame, so it can go up to I can say that you can model it with these line bodies, right? It can be very simple, and in fact, you can even model the entire, let's say, oil and gas platforms, okay, with these particular techniques, okay, and it is simple and it is fast in terms of solving instead of you draw the whole CAD models 3D, okay. Okay, so that is the powerful, okay, of that particular so-called simplified one-dimensional line elements, line bodies. Okay. All right, so that is about using design modelers. So in the case of you want to use space claims, okay, you can also follow the instructions or what we call the step-by-step models. So here again, if you come to here, then you can choose here space claim, then you open here. Right. So the step by step, I think is also quite clear enough when I have shared with you, so you can look into it. So the only difference between these two design modeler and space claim is in space claim we use mirror instead of translate. Use mirror. So mirror, we create a plane at the middles at 3 meters. We create a plane, then we mirror it, then another 3 meters the bodies will come out so you have two bodies, okay, in with a displacement of 6 meters in this case. So what you need to do is basically you go to space claim options. Under unit, you choose the correct unit first, meters, right? Then here precision, you can put 4 so you can see later on your your what we call your units, like the later on your dimension, your length, or in the especially in the I-beam cross sections, you have the 4 decimals. So here we will put 1 meter. So basically, the minor at each minor grid is a 1 meter. Right. Then we can create a new sketch here. Plane. So we want XY plane. So this is an XY plane. We click on it. Then you can just look into this. All right. So XY plane. So you can start drawing line in this case. So click on this, the line itself. Right. We have to make sure we draw you can zoom in. Okay. 1, 2, 3 meters. Okay. Then from here to here is a 6 meter. Coming down is 3 meters. So please make sure you have all the line, and this line are not duplicates. So you don't have more than one line, because later on when it translate or exported into mechanical, so you will have failures in terms of meshing, because you have 2 lines in one, this, let's say this here. So make sure each of these is just one line. So here 6, right? So you have here coming back 3. So here is 3. Here is 4, 3, right? Then this. In fact, you can check. So total we have a 10 line, right? So if you look into here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have additional 1 line at here, so we have to find it out. Just now I think I draw additional line. Right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10. Now we have to create a planes, okay, that displays at so-called 3 meters away from the z-axis. So what we do is we go to create a plane, then we go to home. So you have this, then you create a plane. The here the plane at here, plane was not generated. Right, so what you need to do is under modes, right? Then you have a planes to it. You have to move it. Let me edit sketch gone. So what we need to do, if you are following the tutorial, so you have to create that particular so-called after you have draw it out, right? Then you have to click on that particular plane, because we want to create a bodies, right? So here I have these particular things. Right. So I have a plane coming out here. Then you can have under 3D. So okay, you come to home, 3D modes. Then you move that particular planes away. Okay, 3 meters. Okay, so I have a 3 meter. So later on, for us to get that so-called mirror, okay, we want to do the mirror itself. Then once we have done, okay, then we can click on this edit sketch. So that's the plane that we have created lah. All right. So next will be putting in the mirrors. So if we can select the plane itself, then we put a mirror on it. Then probably we can go to that graphic itself, we can drag this thing, right? We drag all these lines, so now it have create all these line. It's 3 meters from that plane itself, right? Then what we do is we have created that, then we can uh, click on remove mirror. So we have all the line already, we can remove mirrors, then we can edit the sketch. So now we have both so-called side already. In fact, we do not really need the plane anymore. Okay, we can deselect this thing, deactivate these things. Okay, so that gives us the two bodies, like what you have done. Okay, in using design modelers. All right, then we have to create lines for connecting these two bodies. So what we do is you go into select on line, then you put in the 3D modes itself, then you can so-called draw the lines. Okay, so connecting this line to this line. Okay, then you click escape, then connect again for after you have done that particular line itself, you click escape, then here again to here and zoom in a little bit. Okay, escape here to here. Escape. So that give us all the lines. Okay, once you have done, you can click the edit sketch, then you back to all these things. So here we should have 10 plus 10 both side and plus another 6. So here we should have a 26 line. One, if you look into this, select, so we have 1, 2, 3, 4, 5, 6, 7, 11, 12. Right, so total of 26 lines. So all are correct. Right. Then what we need to do is we have now draw the models, then we have to create a so-called a cross section, then we assign to them. So here you can go to prepare cross sections, then we have these I-beams. Okay, then here under I think I have this, why I have this, okay, sorry, we don't select anything here, so we have to create I-beams. Okay, so here come out this, then here we edit a beam profile. Again, W123, T1, T2, T3, we have to key in 0. Let me get back the numbers. 0.1715. Here is also 0.5. Here is 0.3556. Then we have T1 is 0.0073. Same with T2, 0.0073. Then we have T3 is 0.0115. All right, so that completed. You can double check 0.015. Okay, and if it's done, then probably you come back to these designs. Under this layer itself, you have this. Okay, now we want to assign everything to this. So what we need to do is you go to design, select. So select all your 26 line that you have created. Okay, then you go to prepare create. So now you have all these line is giving the beam cross sections. If you still remember in our truss system, we also combine them, right, as a right click it, okay, you select and move to a new components. Right, so this beam now is a components that you have to merge them all. Okay, under share topology, you have to merge it. All right. So that gives us our components. But then if you go to prepare, display, solid beams, so again, you will see that this is under I-beams. It's not really I-beams. So you have to, again, orientate it. So this is I, but not this one. Okay, the sixth line also have to be correct. Okay, the sixth line have to be correct, the orientations. So what we do is we select all these lines, go to file, select, okay, then we select the 1, 3, 4. Here, if you cannot find, then you have to go from the beam itself here to find, okay, select control. Right, so we have these orientates here, right? Orientation, you put a 90-degree. All have been oriented into the eye. Right. So that basically should be completing your so-called models. Have you completed your models? You can put home. So that is your models. So if you can close it and open with mechanical, then you can do the similar setting and basically get everything done. Okay, let this mechanical imports your model from space claim. Then you should be able to assign material, generate mesh, then insert the boundary, the loadings, then you can solve it. Okay, so I have the model out. So if you want to see it, so basically it's this in the cross sections. So all are in I-beams. Okay, so I have tried to orient it already. So what we do is material, make sure it's the correct materials. Then mesh, we can play around with point 2 similar. Then you can generate mesh. So if you look into this, that is a similar things lah. Then we assign so-called fixed supports. Okay, so if you can assign it choosing the vertex, so assign all. Right, and apply the line pressures against. Here you have to choose 1, 2. In terms of the components, y is a negative. Right, then you can call out the deformations, you can call out the beams to itself, then you can solve it. So I get a similar result lah. Basically, the model is same, then probably it won't run away too much. Okay, so I have the similar result 0.015723. That is using space claim.